A novel EEG pillow useful for sleep apnea severity detection and treatment. A feasibility study. My name is Lucas Monter, and I'd like to personally thank you for taking the time to view my project. My project consisted of 3 main phases, each of which are interconnected and serve different purposes. In phase number 1, I created an EEG pillow. The purpose of this was to create an affordable and reusable device which is available to people in all socioeconomic classes and demographics. In phase number 2, I adapted a convolutional neural network for sleep stage classification. The purpose of this was to supplement the hours of intense work which clinicians perform. As a result of COVID-19, clinicians have been extremely overworked, and as a result of extreme tiredness, the clinicians may make incorrect diagnoses. In phase number 3, I conceptualized an app for sleep apnea treatment using operant conditioning. The purpose of this was to create a convenient neurofeedback system. Most neurofeedback therapies are inconvenient to the user. For example, driving to an appointment and training with boring apps. This results in many neurofeedback patients skipping treatment and failing to optimize their results. Given that this app will function as an extension on social media, and given the fact that the typical North American spends an average of 2 hours daily on social media, they will not be inconvenienced by this app. Based on the 3 phases of my project, I created a methodology that would be suitable. In phase 1, I used the Talairac coordinates for electrode placement. These points were 3-dimensional, so I used isometric vector projections to convert the point to a 2-dimensional coordinate. These coordinates were then plotted using matplotlib to create the prototype. In phase 2, brainwaves would be acquired via the electrodes on the prototype and run through a 4-layer convolutional neural network to predict sleep stages. Lastly, in phase 3, a proposed app will use operant conditioning to reduce delta waves which are associated with sleep apnea. In phase 1, I developed a simple prototype using Tinkercad, which is a free 3D rendering program. The image below represents the placement of electrodes for the pillow following the 10-20 electrode system. In phase 2, a 4-layer convolutional neural network was applied. It was approximately 68.93% accurate, which is respectable for any multi-class classification. Lastly, through further research, it was discovered that neurofeedback is approximately 75 to 80% effective. I therefore concluded that it was possible to achieve the objectives of this study. I've always been interested in psychology and psychiatry. I got this idea after brainstorming with my sister and my father. My father had just read an article talking about the high cost and lack of accessibility of other methods for sleep apnea diagnosis, including PSGs and at-home sleep tests. I believed that there must be a better solution, so I began to research and develop a prototype. Due to the current situation regarding COVID-19, it was not possible to perform any randomized controlled trials or RCTs to determine the efficacy of the device. In-person experimentation may have provided even better insights on the project. In addition, using certain programs including Google Colab and Tinkercad was new territory for me and therefore came with an array of learning curves. I plan to continue researching this project, and in the near future I would like to produce a physical prototype and perform randomized controlled tests using it. I would also like to develop an app that could be used for the treatment of sleep apnea based on the principles mentioned in this project. Thank you for taking the time out of your busy day to listen to my project.